NASA has been trying to pave the way for humans to get to Mars for more than 20 years. Elon Musk and SpaceX have the stated ambition of not only sending people to Mars, but making life interplanetary with giant colonies on Mars. And he's putting his money where his mouth is for the first humans to head out to Mars as soon as possible, perhaps even this decade. But Mars is going to try and kill them. It's going to be merciless, unforgiving, and eternally persistent. But in fact, it won't even try, because it's a planet and planets have no mind or agency. It's just a harsh motherfucker that's going to create a massive graveyard of humans that try to make the trip there. But before we even mention the hazards once you get to Mars, the trip there is going to try and kill you too. Now that journey's orders of magnitude longer than 3 days to the moon. You're talking 9 months, and that's ripe with all sorts of issues. Radiation exposure is probably the most well-known issue, and it was only through pure luck that none of the Apollo missions to the moon happened during a monster solar storm called a coronal mass ejection that would give the astronauts a big dose on the way on the way back from the moon, because your spacecraft is no protection at all from those events or big cosmic ray bombardments, unless you line it with some material that absorbs or slows down the bombardment of high energy particles. And while we are able to detect solar storms these days, we can only say a storm's heading your way, take shelter. And that's shelter that doesn't yet exist for either NASA's Artemis program to go back to the moon or SpaceX's Starship, because this is, of course, a question of mass. So it can be overcome. It's just yet another engineering challenge. But you don't want to use lead or thick metal, because a stream of high energy particles slamming into that metal will energize the atomic and subatomic particles in that material and send those flinging off through the spacecraft like breaking in a game of pool. So rather than the particles from space ripping through your cell structure, increasing your chances of getting cancer, it's the particles from the shielding material itself that's tearing through your DNA. And if you're wondering why the astronauts on the International Space Station get away with it, well, it's predominantly because the International Space Station is orbiting so close to the Earth that they're protected by the magnetic field called the Van Allen belt. In fact, when the International Space Station's overhead, it's only 250 or so miles away. It's actually closer than if you were in New York than Washington DC is. So if you're venturing above the Van Allen belts for a protracted time, you want something absorbing like water, which you'll need to take anyway, so why not encasing the spacecraft or insulating it between the inner and outer hull? Now, interestingly, there are colonies of mushrooms that grow around Chernobyl, the big nuclear power station in Ukraine that got all angry in 1986 and threw radiation out in a 30-kilometre radius, and the wind took it even further. Well, the mushrooms growing there were found to absorb radiation and convert it into energy to allow them to grow, and it was still safe to eat. So radiation munching fungi. And they sent some of this up to the International Space Station to perform some kind of experiments on them. So they basically covered half of a petri dish in some of this fungus and then left half of it empty. And when they put the petri dish over a radiation detector and exposed it to radiation, that thin layer of fungus provided a 2% reduction in radiation levels. Now, 2% doesn't sound like a lot, but that's one layer, a very thin layer. So having a rocket ship lined with mushrooms, as stupid as it sounds, could be a way to not only protect from radiation, but also provide a food source as well. But also, there's all the psychological aspects of travelling so far from the Earth, which is enormous. And people say, yeah, well, people go to the International Space Station for 6 months or a year, things like that. But The ISS is still within view of Earth, and the ISS is significantly bigger than anything you'd have going to Mars. And those facts are more important psychologically than you might realise. On the ISS, there's actually quite a lot of room for the astronauts. If they need to get away from people, they can do that. But it'll be a lot harder on a spaceship to Mars. If you're in Earth orbit, you're just hours from returning home in a crisis. On the Moon, you're 3 or 4 days away. Heading out to Mars, you're months or years away, and that will play heavy on the mind. Now, of course, astronauts are picked to be people that are very emotionally balanced and stable, whereas, when you're picking people that say they want to go on a one-way trip to Mars from the public, there's a good argument to be said they're not emotionally stable or rational to start with. Of course, if you're one of those people, do feel free to berate me in the comments below. But once you go beyond the point when you're just hours or days away from getting home, or you're so far away that you can't see Earth anymore other than as just a point of light, which no human has ever seen the Earth like that yet. Even when we went around the far side of the Moon in the 1960s and 70s, and we orbited the far side of the Moon, you could still see the Earth, and you could still see it was a blue planet. And psychologically, you had the knowledge that you could be back there in 3 days. Well, Mars is a different kettle of fish altogether, because en route there's a point that you realise you're on a one-way kind of mission, in the sense that you can't just turn around and drop back down to Earth in a capsule again. You don't have the fuel to turn around, whether you're ill, had a change of heart, suffered a once-in-a-lifetime bout of psychosis, got the news that a loved one is ill. You're still going on a 2-year trip to Mars with a very slim chance you'll actually get back home. And then taking that even further, at certain points in the Martian year, Earth is not going to be visible at all. It'll be too close to the sun. It'll be behind the sun some of the time. And no human has ever been out of sight of Earth, except for a few individuals for a few minutes behind the Moon during the moon landings in the Apollo days in the 1960s. And even the Right Stuff astronauts often tell of having an epiphany when they're up in space and they see Earth suspended in blackness, and they suddenly realise how fragile everything is. Astronauts on the International Space Station often lament the fact that they don't see the colour green and they don't see grass and trees. So we don't know how people will react to Earth disappearing from view on Mars. That's a genuine concern. There have actually been peer-reviewed psychological papers written about this. And it's not just the isolation either, because there's also extreme claustrophobia, because you can't get out. Put yourself in a tight space and tell yourself, I can't get out. Even if you're not claustrophobic, it starts a little chain reaction of anxiety. But in a spacecraft to Mars, you cannot get out for the best part of 2 years. You can never breathe the air again. You're going to be in some self-contained, pressurized either suit or habitat for probably the remainder of your life. You will never feel the wind again, because you're either in a spacecraft or a spacesuit. That's it. There's a very interesting study on the ISS about that, about the movement of air, which seems so trivial, but it was observed that astronauts were getting quite irritable at times, and various things were tried to sort of see what the issue was. And one of the things that was found was that humans require the feeling of movement of air on their body, on their face, every day to basically feel stable. It's such a normal everyday thing that it grounds you. It's part of your sort of psychological makeup to feel the wind on your face, essentially. And they fitted additional fans on the ISS to basically circulate air around a little bit more. So it doesn't have to do much. But it's just that little movement of air, and they noticed there was a drop in irritability and an improvement in their well-being. And the thing is, we've all just gone through a pandemic, right? And, we've all been through those periods of times when we couldn't really go out of our homes as much, and we couldn't go and do things that we enjoy and take for granted. And it drove people nuts, even though they could still go outside into their garden and they could still go for a walk. But we're only just realizing scientifically how stir crazy people got from that level of confinement and not being able to go and do the variety of things we enjoy. We still had the different mental stimuli of driving or walking down the street and seeing different scenery, switching it up and getting out into the countryside for some greenery, and things are looking different. But it's all food for your brain. So imagine being stuck in an area of space that's equivalent to a studio flat with another 3, 4 or 5 people, because that's what it would be like for the 9-month journey to Mars. And you can't go outside. You can't escape. You can't fall out with anyone and row. You can't fume and stew about people's annoying behaviours because you'll go crazy or kill someone or both. And that's just the way there and back. Then there's the obstacles on Mars. Or to put it another way, the ways Mars will kill you given half a chance. Because, going to the top of Everest, where it's very extreme, isn't close to the hardship and dangers of holidaying on Mars. Even if we're talking 15 years' time when NASA feel they're finally ready to head out there, or assuming SpaceX are ready to launch crewed starships to Mars in 5 years' time, which, despite Musk's cool presentations, they won't be. Again, if you think Musk is a genius and will achieve everything he says he will, feel free to berate me for my apostasy in the comments below. But on Mars, it's far too easy to underestimate just how unsuitable for life Mars is. In many ways, we see it with really rose-tinted glasses, as a rocky planet that's quite close, which it isn't, with gravity similar to ours, which it hasn't, abundant water ice, which is harder than stone in winter at minus 243 degrees Fahrenheit. And we think of its atmosphere as a positive, which it isn't, because it's so thin that in many ways it's worse than no atmosphere at all, especially if you're trying to come through that atmosphere and land, which is kind of critical. As for the ease of terraforming the planet, like the movie Total Recall, think hundreds of years with a Herculean effort greater than that needed to reverse climate change here, which we can't do despite all the infrastructure we have on Earth. Mars is simply not made for life, not life like us anyway. The only thing you've got there that you're not going to have to take yourself is gravity. And Martian gravity is a third the gravity on Earth, which is good in many ways, but any long duration stay will lead to bone and muscle atrophy, including your heart. So if you've been there for a few years, and especially if you're born on Mars, your body wouldn't be able to cope with living back on Earth. So even if you could get back, don't, you'll die. So it has gravity, but everything else, you've got to take it with you, because all that talk about how easy it is to harvest it on Mars, it is not easy. So first off, let's talk about oxygen. You need to take plenty of oxygen, not only for breathing, but if you want to get back home, you need 4 to 5 times the amount of oxygen as you do fuel. Now, NASA roughly calculate you'd need 7 tons of fuel and 25 tons of oxygen for the ride back home. And that liquid oxygen needs to be stored in the shade because it'll start to expand and contract in Martian day and night cycles. And you need to hope none of the valves, pipes and tanks, monitoring systems or computers fail over the minimum 3 months that you're on the Martian surface, or that the corrosive fuel doesn't damage any internal components. because we're parking the "let's make it on Mars" line that's often trotted out in a way that's massively trivializing how hard that will be. NASA's Perseverance rover on Mars carries the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, which is demonstrating a way that future explorers might produce oxygen from the Martian atmosphere for the rockets and for breathing. Now, MOXIE weighs 17 kilos and creates 10 minutes worth of breathing air every hour. Even hoping to double the production of air in future, scaling up, you'd need 3 of these per person to keep you in just enough oxygen to survive, assuming you don't exert yourself, which you will, because you'll be fighting against the pressure in your spacesuit on the surface, and you'll be exercising in your habitat to keep your muscle and bone density sufficient for your return to Earth. And that supposes none fail for the whole 3 months you're there. So let's say 5 per person for enough to exert yourself and a spare because you don't want to hear your chum saying, "Can I have a chug on yours?" Now, with a minimum of 3 people on this crew, that's another 1/4 of a ton to get down to the surface. And these things are just experimental. Now, let's say we can make efficiencies and miniaturize it, which we don't know we can, but for the sake of argument, let's be bold and say we could make them twice as efficient again and at half the weight. Then we only need 7 of these instead of the original 15, and it's a mere 60 kilos. However, that just keeps you in breathable oxygen. The vast bulk of the oxygen you need is for your rocket to get back. As we've said before, NASA puts that at 25 tons of oxygen. So using our super efficient and reliable MOXIE that's still quite frankly cloud cuckoo land, we need to take 262 more of these machines with us, find room for them, and hope they work at full efficiency, uninterrupted, from the moment we land without any failing. And that's just the oxygen. Next, we need to turn to water. You've got to take 3 tons of it with you or get it from Mars somehow. And it's not as easy as if you're at the top of Everest, where you can dig a bit of snow up and melt it, and there you are, you've got some water. And you can't just dig up some marsh in the ground, boil it and catch the water vapor from that. It's not going to work in that environment. However, the Curiosity rover sampled the clays from an ancient Martian river delta and found that the water that once flowed there billions of years ago was pH neutral. But that's not quite the same as drinkable. We don't know what else is in that water that might be harmful. I should say was in that water. Especially as we're not just washing our teeth with it, we're drinking that almost exclusively. So any toxins are going to build up fast. And that's the ancient residue in that particular site. We're proposing harvesting the water that's frozen to the temperature that the gas neon would be a liquid. So you'll need some really heavy duty mining and drilling equipment or heaters, with the emphasis on the word heavy. The equipment you would need to take would weigh far more than the 3 tons of the water you're trying not to take with you. It really is just unfeasible for a first visit to Mars. For subsequent visits, if there are any, sure, build your utilities up incrementally, but there is no silver bullet beyond cloud cuckoo land. And if I'm offending the SpaceX fanboys with this heretical talk, again, feel free to abuse me in the comments below. So then, if you're talking long duration, when you've used up your best supplies, your food, which is the greatest morale boost for astronauts and soldiers alike, is actually going to be morale zipping, because you're essentially on prison rations. You don't have the steak or fresh salad or glass of wine that can lift your flagging spirits. If you want a cola, you've got to make a cola, and you can't. You want a beer, you've got to make a beer, and you can't. So next up, we have the Martian environment itself. And we've all seen the movie The Martian. The ground's not great for growing potatoes, but you can do it, right? No, you can't. That's a movie. Something we don't really talk about very much is Mars is really toxic. No, I'll rephrase that. Mars is massively toxic. The soil is fatal to humans in its natural form. Martian soil is full of perchlorate, and it's at such concentration that it's toxic to humans. It's about 0.5% perchlorate, so it's a chlorine-oxygen molecule, and it means the soil is deadly. You don't want to breathe it in. You definitely don't want to water it and let your spuds soak it up to grow so that you can eat them. So, you've given up on growing perchlorate-rich tubers and veggies in the Martian soil, which we're not sure you could even do in sufficient quantities anyway. You're wearing a spacesuit when you're out exploring Mars, but you're going to have this whole drama of having to decontaminate people when they get back into the habitat. You don't see that in films like The Martian. They just come in, they whip their helmets off, but in reality, that soil that their suit's covered in is toxic. Apollo taught us that moon dust gets everywhere, and it'd be exactly the same with Mars dust. So you'd have to do stuff to the soil to change the composition and fertilize it if you wanted to grow anything in it to eat. So there's something else you've got to bring in bulk, and there's something else you've got to do. And the dust itself that's got over all your spacesuit and you're desperately trying not to bring back into your habitat with you is so fine and abrasive that it wears away the joints on suits over time. Again, Apollo showed us how destructive to machinery and the spacesuits the lunar regolith was, even after just a few days there. But your equipment is going to get worn down at the joints, and your fans to circulate air in your habitat is going to gunge up or wear down. Did you bring a few spare fan motors? If not, that'll kill you too. Then the dust in the air on Mars would contain overline, pyroxene, feldspar, things like that, which are the dust you get from quartz mining. And if you know anything about quartz mining, quartz miners, especially in the early days, suffered from lung disease. It's such a fine dust that gets into your lungs and it causes long-term damage. So any astronaut that strolls in from their walk outside, whips off their suit, breathes in the dust, well, the dust is going to get into the habitat. It's going to cause who knows what damage to both the habitat itself and your lungs. So the environment of Mars, regardless of the lack of oxygen and vegetation, is just toxic and nasty to humans. God, I feel like I'm hitting you over the head with negativity, but this is just to show that we can't rely on glib statements like we'll grow our own food or we'll use the oxygen already at Mars, because while we're on the subject of dust, we should talk about the dust storms that happen on Mars. And Mars gets some, really big dust storms, global ones, that can last for months, enveloping the whole planet. And you need to avoid landing in a dust storm that you can't predict or blasting back off the surface during one. And if you're relying on solar power, well, that's a big problem because you can't be going outside in a dust storm to clear off the panels and the sun is literally going to be blocked out. And you need a tip-top power supply for your 262 oxygen-making machines and your water harvesting power tools. And you're not drawing much power anyway, with Mars being so much further from the sun than Earth. And can you really justify having an experimental nuclear power option on an experimental Mars trip? Could it be that close to people en route and on the surface because of the radiation? If you've got your oxygen harvesting machines and your Stirling power generators and they fail, you've got a real problem because you've got no oxygen and power, but mechanically, in theory, you can get them working again. Possibly, if you're an engineer with the spares for every possibility and thorough knowledge of the workings of every piece of machinery between the three of you. But if you've got a problem with your nuclear fission reactor, well, you're in a whole world of trouble. You can't, just call in your nuclear reactor repair guy, and you're all going to die. But the public feeling is that as soon as we've got the rocket sorted, we're ready to go. And we are so far away from being ready to go to Mars, you know? So I come back to that comparison with exploration at the end of the Victorian era, where people were desperate to go and conquer Antarctica in the same way people now want to conquer Mars. Back then, they just didn't have the technology. It just wasn't a viable thing to do. But they did it anyway. And most of the people who tried it died or were seriously injured and the mission failed. Think about Shackleton's mission, which was a glorified failure like Apollo 13. And he still died down in Antarctica. Captain Scott, of course, died horribly. Amundsen made it, which masks over just what a mortal struggle it was to trudge to the South Pole, plant a Norwegian flag and get out before everyone died. And we're even less prepared for a jaunt to Mars. Musk building a Starship does not a Mars mission make. Last year, he was mostly blowing up a lot of stainless steel in Texas. He's not even begun blowing up boosters yet, as I'm recording this, and no Raptor 2 engines have even flown at the time I record this. We are just so far off, even if we had the hardware, which we don't. Maybe in 5 or 10 years we'll be closer to something that inspires confidence, because the fact is that none of these issues are trivial, and there are so many engineering problems that need to be solved that you can't physically do them all in a year or two, not even Elon Musk. If we revert back to our suicide mission using existing rocketry, that's possible because you don't need to worry about landing 32 tons of fuel to get back. The weight of the return launch hardware that houses it, 3 tons of water, half a ton of basic food rations, however much a Mars rover weighs, because you wouldn't go all that way and only venture a few hundred feet from your lander. For a return mission, if everything goes flawlessly, you've got to land probably 50 tons extra on the surface to survive long enough and get back to Earth at the next available launch window. The best landing system we currently have can put just under a ton on the surface of Mars. Starship holds the promise of putting over 100 tons on the surface of Mars and then being both a habitat and a launcher to get back to Earth. But it's not even a full prototype yet. It's not flown to orbit or landed safely from orbit as I record this. It's not human rated, and it's certainly not put any payload on anybody in the solar system other than on the Earth with a basic boilerplate of the top section. That's maybe 20% of the equipment needed to be considered a functioning human rated spacecraft. You know, absolutely everything you need, you've got to take from Earth, which to me just says, as much as I'd love to go tomorrow myself, it's just too damn difficult and dangerous because we haven't evolved to live on Mars. We've evolved to live and thrive on Earth. But to end on a positive note, I will say that these are not necessarily problems that we can't solve in the future, maybe even in the very near future, in the next few years. Eventually, we will figure out how to get enough oxygen from the Martian atmosphere or soil. We will figure out how to get enough water in situ. We'll figure out the soil problems. We'll figure out the radiation problem. We will get there because humans are clever and curious and ambitious and adventurous. But should it be 100 people like Elon Musk wants, who are just going to go there and die in a billionaire's dream to make life interplanetary? Certainly for the first trips out there. You can't see it being anything other than like a Jamestown, where all the first colonists die. Tell me what you think. Drop them in the comments. And it's also worth pointing out that we went to the moon in the late 60s and the early 70s. It's been 50 years and we've not got back yet because it's damn difficult. And that's the moon, which is basically on our doorstep. This video is just one in a 3-part series on NASA and SpaceX's Mars ambitions. So if you've not seen either of the other ones already, you'll definitely want to check them out.